Welcome to the class. Here's where we're going to kind of go with this. Not necessarily in this order, okay? It's just because everything kind of, uh, you know, uh, all comes at once in a sense, right? So I'm going to try and get some understanding of things. Now, this is, there's some things I may skip over quickly. If you don't have an understanding of them, you might want to ask. Understanding the MaxScript help is a big one, and actually understanding how it functions and works. Unfortunately, they've changed it for Max 2012, and quite frankly, it's just not as good. They've gone to the web-based system, just like what's in Maya, if you've seen it, and I absolutely hate it. But that's what we're stuck with, so we're going to have to try and live with that one. Inspecting, creating objects, how to get around and actually figure out how to deal with objects and everything. Transforming objects, through the basic move, rotate commands and everything. Variables, arrays, and for loops, in case you don't understand those. Not everybody does, so I want to breeze over those really fast. And then we're going to get into the transform matrix and discuss that, because it tends to be one of the areas that people know least about. It tends, and they're scared of it. They don't understand it, they don't get it, and they're scared of it. So we're going to try and discuss the best understanding of that. To date, still with Max, probably your best information on the transform matrix is Bobo's DVD from CG Academy. You can purchase it there if you like, and basically he does an amazing job. I mean, Bobo's the man when it comes to knowing this stuff, considering he writes the MaxScript help. So he does an amazing job in that DVD. Creating bones and hierarchies, we're going to get into sort of how those are dealt with. Again, something that people don't really understand. We're going to deal with actually trying to capture what we've already built so that we can reuse it. So writing some quick code that's actually going to grab what we've got to make our lives easier. Adding IK solvers and dealing with those. And then we're going to get into some more structural ideas about code. How to work with functions properly. Anybody in here not used a function yet? Just say, just fire up there if you can. Not used a function, doesn't know what it is. I'm just trying to get a level of information here. So please put up there that you've not used it. Structures, same thing. We're going to start looking at how to deal with structures and how to use structures to be able to better structure our code and better structure data. Hopefully as well, so we'll hopefully get into that. Recursive functions. There's another one people don't usually don't understand as recursive function. How many people here know what a recursive function is? Rollouts, UI items, event handlers, and all that kind of stuff. Sounds like most of you probably started using that, but we're going to get into that and dealing with that stuff. And then doing things like flagging objects and storing data in objects so that we can actually flag and store excess data and know how to do that. Good stuff. Okay, recursive functions will be good for everybody. And then we're going to start looking at controllers again and dealing with controllers, parameter wires, constraints, list controllers, and how to write some tools and functions around those to start simplifying our code and whatnot and making it a little bit better. So what I'm going to do is, without any more time wasted, I'm going to start diving into writing some code here. And into Max, into our MaxScript editor and whatnot. So again, I hope everybody knows where this stuff is. If you don't, MaxScript editor, MaxScript listener. Real quick definition of what's going on here. We have the recorded area here. So if you turn on macro recording and start building objects, it will record the items here. This is the sloppiest, ugliest, messiest code ever. Essentially, basically, I tell people learn to do it properly, because what's written here, even it was amazing in MaxScript. There's even cases where it'll record the stuff, it'll actually not work. It'll actually throw errors when you try and put it in your code. So I almost never sort of even look at it, just because it. Down below, of course, where it's going to be recording error messages and feedback data, and of course our MaxScript window, which is tab. Now I've done a couple of things, and if you take a look, we have a user options file here. I'm just going to create this, make this larger. To start off with, you might want to look at this. So this is under the open user options file. And if you look at the help, it'll give you information about what these things do. But you're going to notice as I start typing, so this is the MaxScript user properties. So again, if you didn't see it, open right here, user options file. A lot of people don't know about this, but it actually is really handy. And if you add these lines that I have here, basically one of the things it will do is an autocomplete. You'll see there's a autocomplete information here. And this is really handy because as you start typing and you start typing words that have already been used in your code, it'll automatically want to fill them in for you. So it'll save you making errors on things like variable names and whatnot. So you'll be able to do that a little bit faster and easier. The other one that I use a lot is abbreviations. And you'll notice I've got a pile of them here. These are abbreviations. Let me just scale it down. So you'll see that what I've got is a whole lot of stuff going on. Take a look at your abbreviations. Basically, you can come up with abbreviations file that says header equals, and then you basically put lines of information, and from that you can just it'll actually put this down. You'll find out if I type the word header and then hit my hotkey. It will actually abbreviate that header into this entire string of information right across and write it all out into the script for it. So it can make it really, really fast for writing functions and comments and comment headers and structures and whatnot, plugins. It'll lay down the headers and everything. So I don't know if you guys know about that. That'll as you get better at it and you know what you should be writing and don't want to keep writing it over and over again like for loops, you can type something in and bang, you've got it, and it's there. So in this case, I can write for X and just hotkey and away it goes. So the hotkey for it is where is it actually? To be honest with you, I forget where it is in the expand abbreviation right there. So when we type the abbreviation, we'll be able to go Control Shift A and we'll get it. So let me just show you that in action really quickly, and just create a new. I just did Control N. So if I actually write header and go Control Shift A, there's my header now done. So you can see that it's a whole lot faster and easier. There's a function really fast with a commented area above it and everything else. One of the things I noticed that new guys doing in code don't do enough is comment everything. And I mean a lot. I comment my code a lot. Maybe I'm just not that bright when it comes back down back to reading my own code. But what I find is you'll write functions and whatnot, and they're one of those things that you give it a name that looks like it may mean something, but when you come back to your code 6 months from now, what does it really do? How are you supposed to call it? What are you supposed to pass it? What other functions might call it? And start keeping an organization in your code of comments that actually allows you to know what it does. Things like a header here. What does a script actually do? You might have written a script that was this quick little script, and the name doesn't tell you necessarily what it does. Make sure that you actually give information in here as to what it does, how it works, and whatnot. Okay, so it really helps. As well, you guys are in production. Who wrote it? And if you all start using the exact same header information and formats, you can do even more than that. You can start reading into your library of code and reading out your header information into some sort of list that you can see what all of your different scripts do as well. That's what I've got in my arsenal. Basically, I've got code that reads all my coded scripts and actually feeds back to me the header information, the function information, so I can go back and actually inspect scripts without opening them really, really quick and fast. So I'm just going to get rid of the header just to keep it nice and clean here. So. Understanding the MaxScript help, and this is just a quick one. So if we type in box, and we're gonna, because that makes us a box, and hit F1, Unfortunately, now it seems to be slow as anything coming up with the UI, but it goes and does a search, and this is one thing that drives me nuts, that it brings up the search now, not the index. And the index just doesn't work as well as it did either, in my mind, because it doesn't isolate it all. You have to sit there and filter through everything to find it. And I'm trying to find out where box is now. Box geometry class, box creation examples. So with the MaxScript help, let's see if I can size this up. Yes, that better, guys? Probably see that a bit better. Whenever you see in the MaxScript help anything inside of greater than less than signs, that means that that item is necessary in the code. Okay, so you have to pass it that information. See if I've got we'll come up with better examples as we go. So anytime you see this piece of information is necessary. Anytime you see square brackets, which I don't see any listed in here anywhere, which is kind of odd the way they've done this one. Anytime you see information that's being fed to you and told you could use, I'm trying to find a good example of that now, and I had one yesterday, and sorry, I've suddenly forgot what I was looking at. Anytime you see square brackets, though, and I'm sure we'll find it along the way, that piece of information isn't necessary and can be left out. There are variables and whatnot that can usually be left out. So as we get into that, we're going to start looking at that and using that information. So the key index, and unfortunately now is a pain. If you can get MaxScript 11 help, 2011 help, and use it, problem is it won't contain the new things. So I tend to go back to it sometimes with things I know where they are. But what's nice about the MaxScript help is you don't have to have that version of Max open to launch it. You can go launch it directly out of your folder systems in Windows. So, I basically have it able to be launched, so I can launch the different versions and see what's there. Sometimes also I'm trying to develop backwards, but I happen to be working in 2012, and I need to be able to develop a tool that's going to work in Max 2009, and I need to go see if a command actually exists back then or back further. Somebody had me coding for Max 8 not too long ago, and that was confusing as anything. Kept writing stuff that didn't work. So we're going to get around this some more as we go. But the search and, of course, contents. And if you guys are learning, I don't know how many people have done it. The learning MaxScript, getting started is all really, really good. The vector information, trigonomic functions and whatnot, excellent. Go through all this stuff like crazy. How-to practical examples is actually probably one of the best things for somebody who's already got to start. If you haven't gone through all of these, do them. Whether you think you know what you're doing or not, do them. Because when I went through and did them, it was like, oh man, I never thought of doing it that way. So some of them you'll skip through and you go, know it. Other ones you'll get through and you'll suddenly realize that, wow, didn't know it. So I would go through this and start doing this, all of those examples. So creating objects and whatnot, pretty straightforward. I assume most of you have done it already. So box will get you a box on screen. And of course we can then start inspecting those boxes. So show properties or show will actually get you that information. In MaxScript, $sign represents an object. And if you guys ever if you're using $sign, so I assume, again, you guys probably know this, that if I highlight just the $sign, Shift Enter on my keyboard, it'll feed back what I currently have selected in the viewport. The problem with it is this. I'm just going to create two boxes, select both of them. You'll notice it returns selection. I'm just going to do a quick test here. I'm going to say class of. I don't know if you guys have seen class of, but basically it's a command that will get you the classes of things. If I say class of, for instance, one object, it returns me box. So it's returning to me a box at this point, $sign. If I select both and say class of, it returns object set, which is basically an array. So the dollar sign on itself is actually problematic. Never use it in your code by itself. It should always be followed by a name. Okay? You should never ever open up code and see somebody referring to $dot height. Okay? That's really, really sloppy and could cause all kinds of errors for end users, because if they have two things picked, it no longer returns an object, it returns an array. Okay, so use it in your quick test code maybe, but don't use it any further than that. If I do a shift enter on show properties, it's going to show all the properties that we can get at and all the to access and be able to deal with. So we can get all of the property names, as well as all of the values that need to be stored in them. And so understanding those is important as well. Float, typical float value 0.2, integer, whole numbers, Boolean values, true and false, and get to know what all of the value types mean. If you don't know what they are, probably the best place to find them, maybe doing direct searches in there is good, but even if you look up scripted plugins, will give you a really good idea of what they mean as well. There's a whole breakdown in there of them that, so if you look up scripted plugins. So inspecting objects is good, because we can go in and we can find out the information for a box. So we're going to do it properly here, and we're going to call this, I think this is probably box 02. Just going to grab its name. Oops. Let me just slide my panel over. In this case, we're looking at box 02, so the one I've currently got selected, and .height. And if I run that again, shift enter, it'll feed back the height of the object, and of course, again, equals 50, and I just changed the height of it with a shift enter again. Okay, so transforming objects and getting into that. So there's a couple of ways to deal with transforming objects. And we're going to kind of get into handling transforms in two ways. There's the move, rotate, and scale commands. And these commands work well, but I don't always use them when it comes to putting together how to move an object. Oh, this help drives me nuts. It really does. I should just bring up the old help because it is it's such a pain. The old one would get me right there. I mean, every single time when you do a check on something, it would drop you right to the where you want to be. This just never does. I have no understanding of why they changed at this point. Move. Yeah, see, this comes up with everything under the sun. It really does. Anybody find a really good solution around this? Please tell me. So basically with the move option, we list the move command, the object's name, and then a position XYZ value. Really, really straightforward. Really, really easy to deal with. Rotating is a little bit different. And this is when it gets into one of those areas that people, again, don't quite understand when it comes down to it. How to rotate, scrolling through trying to find R here. Yeah, because it doesn't give me what I want. UV mapping, it's like... rotating is a bit different. Rotating objects, what you guys may have found in Max, is a little bit of an oddity. If I ask for the rotation of an object, so $rotation, what I get is this funky quat value. And right off the bat, here comes one of those things that people don't understand. What is a quat value and what does it actually do? A quaternion rotation is actually more accurate than an Euler rotation. So when we take a look at the dope sheet and we look at the rotation of an object, what we see by default is XYZ, and actually Max 1 through maybe 1 and 2, maybe it was 3 they changed it, I don't remember now. Quaternions were the default. But essentially all apps use quaternions under the hood and Euler rotations for the end user to view and animate with. An Euler rotation gives you a breakdown of 3 axes and function curves that are understandable to an end user, mostly. That's a big disclaimer there. Mostly understandable. Quaternions are usually completely not understandable because there's this higher order math involved, and that's an object that's not rotated. And the best way to think about it is like having a sphere with an arrow pointing out from the center to the outside edge of the sphere. And what you're doing is you're moving a point on the outside surface of the sphere around, and the end tip of the arrow is touching that point. And if you move that point around the outside of the sphere, the arrow will always touch it. And then you can twist the arrow around. And that's kind of the best explanation, or sort of easiest explanation of it. The problem with a quaternion is for instance, a ball rolling, or something rolling down the x-axis in your scene over and over and over again, so around and around and around, will not rotate if you take the object and rotate it 360 degrees. So if I were to rotate this object right now with animate on, and say rotate 360 degrees, turn on my angle snap, it's using an Euler rotation right now, and it rotates perfectly fine. If I take the other box now and I change its rotation controller to a straight up quaternion rotation, what's called TCB in Max, tension continuity bias, and you'll notice there's no more tracks of animation, no more separated tracks of animation. I take the same object now and I rotate it 360 degrees, and I scrub. You'll notice one box rotates, I think you guys can probably see that, and the other does not. It doesn't rotate because if you consider this, oh, fabulous. Thanks, Alexander. If you consider the way that sphere works in a quaternion value, when that point rotates around and you move the point on the sphere from the top all the way back around to the top again between frames, it hasn't moved. It's gone from the top to the top. It hasn't gone from 0 to 360. It's simply gone from the top point of the sphere to the top point of the sphere. In other words, it stayed still. Okay? So quaternions can be a problem in that sense. However, they're more accurate rotation value, okay, because of gimbal locking. And I'm sure you can read up on gimbal locking in all kinds of places, and so I don't have to get into it so much today. But what I'll tend to do is use my quaternion values as much as I can for actual rigging purposes, and not Euler values. To get at the Euler values, we can use this breakdown, which will give us our converted to Euler values, and we can work with it this way if we like. So there's always an extra step, and when it comes to using the move functions, or sorry, the rotate functions, we want to be able to convert it to Euler angles. So we need to use, and then we can give it the x, y, and z values that we want to use. So we'll 0, 0. Oops. And that will rotate our object a given amount based on Euler angles using Euler values. But it is actually working and being converted down to quaternions all the time. So really this is the best way to sort of just move things into place. Scaling, same thing, you can look that up, it's pretty straightforward. So let's take a look at, right off the bat, the transform matrix. This would be the way that I do it the most, using your transform matrix to get objects around your scene and to work with those and to manipulate them. How many people here believe they understand the transform matrix right now and use it and build matrices and multiply matrices together and whatnot? $box01.transform, and here's our transform matrix. I assume you all can see that value. It's as much as I can scale it in. Most people don't understand what this is and what it actually means. So here's the way it breaks down. So here's the best way to look at it. What this value does, it actually describes the position, the rotation, and the scale of the object. And you guys have probably heard me, if you've followed any of the web boards, tell people over and over again, do not scale objects. If you've done my DVDs, you heard me complain and tell you, do not scale objects, especially in a non-uniform way. And the reason being is essentially things like your rotation value that starts off as an Euler to the end user is converted down to a quaternion value. That quaternion value then is converted into the matrix, and the matrix then is passed on to the next object in the hierarchy. So there's this hierarchy of steps that takes place, and it can affect it. And the reason being is this transform matrix contains all three of those values. Now, the simplest one is what's called row 4. Okay, so we're looking at the last one here, which is the position of the box. This is pretty simple. I made a box. It's at 0, 0, 0. It states 0, 0, 0. So this is pretty easy to work with. So if I actually state dot row 4 and run that, there's the value of it. Oops. For some reason, I keep hitting something on my keyboard lately that changes my keyboard to French. And I'm telling you, that doesn't help me at all, because I keep typing the wrong things. So what I did is I just put the value in there, and strangely enough, it doesn't error, but it doesn't allow you to actually directly input a value in like that into a transform matrix. So you can see that I ran that line of code, no error, just didn't do anything. Okay, so you can't directly add stuff into the rows, but you can directly pull the values out of the rows using this method. Okay, using dot row. You can also do it via sort of an array value, and you can pull it via that array value out as well. I tend to use dot row for and whatnot, just because it's just really clear to me. Again, it kind of depends on how you code, how your shop codes as well, because you need to be able to read each other's code usually. The next values, though, are the tougher ones to understand and to work with. This one's easy. It's these three that people don't get off the bat. And what you've got here is you don't have an XYZ rotation or an XYZ scale. What you have is an XYZ vector. Okay, so this is a little tiny point. If you don't know what a vector is a unit vector, they refer to it as, is essentially a point that is 1 unit in length, okay, and is only 1 unit in length, and points in a direction from 0. Okay, from 0, 0, 0. So in this case, what we have is we look at the Z vector. Okay, the Z vector, if you can imagine at the 0, 0, 0 point of this box, okay, so wherever this box is, basically, it's considered 0, sort of the local 0 position point, so wherever the box is. What this is saying is that the little arrow that points up along the X direction, so in the direction that Z points, sorry about that, in X, it doesn't point towards X at all, 0. It doesn't point towards Y at all. It only points straight up in Z for this object in world space, and it points up 1 unit in length. So it's got it's a little arrow that's a little 1 unit long arrow. Okay, and so if we want to see what happens when we rotate this box over, and we just rotate it over 90 degrees now, and we run our line of code again, what we get is this new, and you can see how it's changed now. So this is the box that's been rotated over. Notice the position value hasn't changed. That's pretty obvious. Notice the X didn't change. Well, what's strange is I just rotated it around the X axis. Let me create my axis a bit bigger here. If you notice, I actually rotated around the X axis. So I rotated around the X axis, but the X value is the only one that didn't change. All right, so follow that. That didn't change. Therefore, it's not a rotation value. Okay. If you notice, the Z now has changed. The Z has actually changed completely because the Z value is 0. So what's it's saying now is that I'll just go to local mode here. I'll go to my position icon so you can see it. The z vector that's pointing along the that was pointing up the z for the box now is actually laying flat along and pointing along the negative y direction. So we've actually, this z-axis is now pointing along negative y. Okay, it doesn't point up at all. The y also had to move, and so instead of rotating this box, what this matrix did is it actually moved 2 points. It basically moved the z from here, moved it down to here, moved the y from over here, and moved it up to the top point. Now that what you've got is you've got these vectors changing on you. Okay, so there's no rotation. Here's why. Rotations are nasty in 3D space, in any application, even when they send people to the moon. Rotations are nasty. Okay, there's always a problem with them. Quaternions don't wind up. Eulers have gimbal locking, and every other solution has some sort of problem to it. Okay, there's no answer to that that issue. The answer is using a matrix to be able to define it. So this is an object that's been rotated over. If we take a look at 45, oops. Yeah, sorry, that was the whole just going off the screen. I'm gonna have to zoom back a bit. There we go. If you look at a 45 now, what you've got is, again, your x hasn't changed, and we have 0.707 in the y, 0.707 in the z. So again, this is the old, back to your grade 8 math class where you're looking at. Here, I'll do it on this grid here. Where you're looking at a Cartesian graph and you're graphing something. If you graph an arc from the 0 point up and out, along your x and y, and you create an arc in that graph, this point 45 over in your arc, okay, actually isn't out here at this point. So these values don't aren't even numbers. The reason being is this unit vector needs to say 1 unit in length. So this arrow still is only 1 unit in length. So it's somewhere here and not out at our meeting point of the two whole values. So it's a 0.707. So does that explain kind of where those values come from so far? About to show you that. Okay, so where's scale exactly? Let's see where this problem comes into. What causes the problem? So again, I'm just going to clear out here. By the way, Control D if you didn't know it. So I'm back to a box, all lined up again. Okay, so now let's take our object and we'll scale it up, and we'll scale it up 200%. In the or thereabouts. I should have just typed it in. There we go. So there's our scale of a box. And let me just get a new line here. Let me just throw that in and do that again. There we go. So here's our, we're not quite at that value. So here's what we have then, is we have our unrotated, unscaled, unmoved object, and now we have a scaled one to a value. We'll call this 2, okay? I'll just do that just for simplicity's sake right now. Essentially what we're taking then is the z vector, because we've now scaled it up, so that point, that unit point that is 1 unit in length, what we've done is we've broken the rule. It's supposed to stay 1 unit in length, okay? And what we've done is we've grabbed it and we've moved it up, and it's now 2 units in length. So it's no longer a unit vector, it's 2 in length, okay? And what this has done is it's scaled the object, and it's pulled the object up. And you say, well, so what? The problem is we start doing math with these matrices, and what happens is each matrix gets passed on to its children for the children to determine where they are. Every object in a hierarchy is dependent on its parent. So its position, rotation, scale values are based on its parent. If there is no parent, it's world space. World is a parent, by the way. I mean, there is basically an invisible scene node that represents the scene, okay? And it has a transform matrix. And that's how you can scale scenes. So the idea being is that this value can get scaled. So if we wanted to actually go about scaling this object, we can actually do something simple. I'm just going to use the cheap $. And we can start pumping this value in. So we'll just make sure it's scaled exactly. Oh, sorry, matrix. Transform, sorry. It's one of those things, talking and chewing bubblegum kind of scenario, right? So, and what am I getting? Missing a set of brackets. Lost that in there somewhere. There we go. Sorry about that. So we can apply the transform and we can scale it. So we can scale it back down to its starting point by changing that back to a 1. Here's the problem with matrices. As soon as we go and create a hierarchy, okay, so what we're going to do is we're going to create a hierarchy of objects, and we can then scale that object back up to 2. And we decide now we want to link this one in, so we set the parent. And you say, well, big deal. So what? Everything seems to work fine. We grab our child now and we start to rotate it. Look what happens to the child. Anybody seen that before in their rigs? And go, what in the world's going on? So it's skewing because, yeah, exactly, yep. So what's happening here is you can, never knew why, exactly. And here's why. So essentially what you're looking at then is that this object's matrix, its vector in the Z, okay, this Z vector, has been stretched up to this point up here. I'll try and explain that. So essentially what happens is this pulled this vector up. This one now inherits the transform matrix of its parent to calculate its own values. So when we rotate this object, and it's rotating based on this one, what happens is as we rotate it around, that vector is still pointing straight up. It has to be relative to something, okay? So when you're rotating the object, there's no such thing as a local rotation. Because if I locally rotate this over, its value is still 0, 0. You can see my rotation values here because I'm in local mode. Parent is the one that is valid. Okay, so as far as the matrix is concerned, what it's using to finally calculate this Euler value has been scaled straight up. So when we rotate the box 45 degrees over, it's now skewing it. It's now trying to skew it straight up. This is why scaling objects, especially non-uniformly, is a bad idea when it comes to rigs, because this can get really, really nasty and cause you all kinds of problems like this in it. So we want to make sure that they're all, we've removed all of that information. Now, if you're wondering what reset transform does, it's pretty simple. Let me actually just rotate the box over somewhere. We've scaled it, okay? And we use the reset xform utility, and my box didn't move. If you notice, the bounding box did. It suddenly popped. Well, what's happened is it's applied an xform modifier. People think it's just the xform modifier. No, it's not. Let's just turn off the xform. There's our box unscaled, unrotated. Okay. So what reset xform does is it takes your object, it rotates it back to align to world space. It unscales it so that it has a normalized matrix. Okay. It then sticks an xform modifier on it. It goes into the gizmo mode of the xform, applies the rotation that was on it, and applies the scale value that was on it into the xform. Now, of course, an xform isn't changing the transform matrix. It's merely moving all of the vertices of the model. So the model no longer has a scale value, no longer has a rotation value on it. It's reset the object using the X form. Does that explain it, guys? Esteban, okay? Does that mean okay you get it, or okay you think you get it? As you poke at it more, it'll probably start dawning on you more and more as you poke at it more and more and try to figure it out for yourself. Yeah, I'm sure you will. Have to go over it again, Tristan. It is a bit to chew on, but again, at least now you've got an idea of where to start with this bit of information. When this light went off in my head about how this works, it suddenly opened up a whole bunch of new possibilities. For instance, knowing that you could write your own look at constraint using a script controller. Because if you can control the vectors and the direction the vectors point, you can actually build yourself your own look at constraint. So with this transform, what you can do, start doing is you can start multiplying values together, and you can start getting different values. And this is going to be important for us again. So let me just do a box and a box. I'm just going to grab one of them, move it up, and I want to parent these two together. Okay. So from what I was telling you guys, essentially, the value of this box, let me just make sure the position value of this is something really obvious. We'll call it 20 units up, maybe a little higher. We'll go 40 units up. So this box sits at 0, 0, 0, unrotated. This one sits 40 units up. Let's take a look at those values quickly. There's the transform of that one. There's the transform of that one. So, sorry, I'm being a bonehead. Let's do it this way. So I can just do it by picking. So there's our first box sitting on the ground here. Position value 0, 0, 0. Second box makes sense, 0, 0, 40. Both are unrotated, both are unscaled. But this is a child of this one. And like I said, everything's relative to it. But the interesting thing is the transform matrix always returns a world space value. So even though I was telling you that essentially everything is relative to its parent, the direct transform matrix value is always feeding back to you the absolute world space position rotation scale values of that object. What we can do is we can go about getting that information in its actual space by doing some multiplications. You've probably seen this stuff done a little bit. What you do is you can't add or subtract transforms. You have to always multiply them together. If we take a look at this value then, and this line of code, what it's doing is saying take the transform of this, multiply it by the inverse. And if you want, you can look up what an inverse function does. But it basically inverts. It turns a matrix sort of inside and out. All right? If you think of matrices as rows and columns, a true matrix really, in mathematical terms, is usually shown like that. Okay? With rows and columns, okay, and they would usually be for a transform matrix 4 values. If you look it up in pure mathematical terms, for various reasons, the fourth column is not used, okay, for doing matrix manipulations like this, but generally needs to be there under the hood, and I believe Max under the hood adds it back in, but it's not needed, so it only shows you this. The idea being what we're doing is we're going to get the local space. So we're going to find out what the transform matrix of this box is in the top, our top box, is compared to its parent. If I run this right now, it returns the same value. That's because our box at the bottom is still at 0, 0. If I move it up, and I ask for just the transform matrix of box 2, so I'll highlight just this piece of code and run it, you'll notice that our position value changed. But if I run the whole line, it's still only 40 units up. It's 40 units up along the Z. If I rotate this object, ask for just the matrix of box 2, you'll notice that it's rotated. Some crazy numbers there in the rotations. Those will all be unit vectors, by the way. We can test that theory. asking for a length, by the way, with the length command. And you'll notice the position is completely changed. But if we run the whole line, we'll get its local transform space again. Okay, and you'll notice for some reason it's feeding back an exponent value here. So this is basically 0. Whenever you see this e in here, but that's essentially 0. So I'll just zero it back out again so you can see it a bit easier. It's still 40 units up. So this is actually getting this box's transform compared to its parent. You guys follow? I'm just going to make a sphere. Add a sphere into the mix. Create a variable. I assume you guys all know variables, so I'm not going to go over them at this point. So I'm going to create a variable called tm. There's the local tm value of this transformation that's going on. So you know what I'm going to do is I'm just going to move this out of the way, show you the 0, 0, 0 grid space here. Let's take our box. You know what? I'm going to make another box because it'll be more obvious. My pink box. My pink box isn't linked to anything. What I've just done is I've grabbed the local transform, basically. Okay, so the local transform, we're going to call it, of box 02 compared to its parent. And we're going to apply it back to box 03. Or box 003 now in... That's all it did. Show you that again. Let me move it, scale it. So where it's applying it to is its parent. We've got this value. So again, transform.transform is an absolute world value. We're applying this TM back to a world space value. Okay, so it's popping exactly where it should be. As you would assume, 40 units up, right above 0, 0, 0, unrotated, unscaled. Okay, if we want to actually get it to be here and set it like it's actually a child and right above the box 2, what we need to do is go a little bit further. We need to multiply it by the object that we want to use as the transform. Okay, so we're going to sort of say box 01 is going to be its parent. Now it's not actually parented to it, but we're going to apply it relative to box 01. So we're going to take that TM, multiply it by box 01's and apply it now. And guess what? There it is right on top of the other one. So let me just go and grab it. And let me just do something to make it more obvious. And I'm just going to make it see-through so you can see it. So you can see that it's applied it. It's not a parent. I'm hitting page up. Okay, it's not a parent of it, but we can apply it back into it. So can you imagine now what this is capable of doing? How about we actually flip it over and get it to be on the exact opposite side and mirror the object and place it on the other side. So we could say, well, where would it be if we wanted to mirror it across the other side, and how are we going to do that? What you can do is you can then start multiplying matrices by other matrices, and you can make those matrix values up in the help. So let's see if we can find it in this help file. Using transform node, what's it under? I think matrix 3 we want to look up. Wow. God, I hate this. I'm gonna. As soon as I didn't even know they'd put up that that other. Come on, M. Can't even roll down through them. This is the ugliest possible help file I've ever seen. Matrix 3 values. There we go. And so we can convert values to matrix 3 values. You can actually take a quaternion, convert it into a matrix 3. Take an Euler angle as a matrix 3. You can create rotation matrices and scale matrices and trans matrix values. So what we can do is we can actually create matrix values that represent certain matrices. In this case, what we can do is we can do a big no-no and scale. Anybody know why you don't use the mirror tool here on rig parts? Anybody tell me why? You got it. It's inverting the matrix. It's going to take one of these values, so our unrotated object here, and you mirror it along X, it does this. Applies a negative scale to it, exactly. So all of a sudden, for all intents and purposes, mathematically, that object is now inside out. And what it does is it flips the normals over for you so it doesn't look inside out to you. But if it didn't flip the normals over for you, you'd be looking at it going, why is that object inside out? So what we can do is we can actually scale this object, and we can scale it around and place it on the other side. So we can just do this again. We'll just do, well, I should just be able to do it here. We can say, and I've got it in the wrong order. You can see that it's scaled it and flattened it. So you can apply a matrix by generating one. If we look at the scale matrix, and I'll just take a look at what it looks like. Here's a scale matrix then. So essentially it has no position value, no values in the other axes, and that's why it flattened it. What we want to do is we want to make sure that we actually -1, 1, 1. And you'll notice it's flipped it over. And it's popped it on the other side based on this object's axes. And what you might be saying is, well, yes, do you say that's Mark? That's a yes. And actually, get rid of it from all of your artist toolbars. If you know how to use it, you can use it actually quite wisely. So the problem with this matrix now is that we've just generated, if we look at its neighbor over here, so it has an x value pointing one way, it has an x value pointing the other way. This is a problem, okay? This is a definite problem with itself. Mirror modifier, yeah, but you can't mirror bones over and stuff because the mirror modifier does not mirror the transform matrix. It will not take the transform with it. It simply moves all the vertices. So it's no good for rigging. What you need to understand to be able to do here is how do you actually utilize the transform matrix for getting things around the other way. So here's one of the things. We've just mirrored across an axis, X, okay? And we've popped it on the other side. But can we actually now mirror this and unmirror it? Because if you think about it, if we can mirror this now around itself, we could unmirror this and have it stay put and get rid of this this value. So what we can do is we can actually unmirror itself. So we should be able to do, again, I have to stop and think about this myself before I lie to you. Boy, I have to think about this. One of those things, I do it all the time, and now no, it's going to pop to the other side. Oops. There it is. It's a matter of figuring out the order. So if you notice, it just popped it over the other way. So now we've got what the bone mirror tool does. And if you notice, bone mirror tool only mirrors bones. You can actually mirror anything this way. Okay, so this is exactly what the bone mirror tool is doing. What we just said is what we want to do is we want to flip an axis. And in this case, we flipped X. Okay, sorry, we flipped. Yeah, so X, if you notice, is pointing the same direction. Y and Z vectors have been mirrored. So this point here has been mirrored over to this point here. Y vector has been mirrored over to the Y vector, but the X vector isn't over here anymore because that would be an inverted matrix. It's flipped over and pointed on the other direction. So what I've just written with these two lines is the bone mirror tool using matrix values. So now when you want to be able to write a script that goes and takes a rig and invert it and build the other side for you, there's the code right there. You're basically starting off by figuring out matrix values from children, where it's going to be. You can just do it in greater world space. You wouldn't even have to deal with this piece right here. Okay. But essentially what you're doing is you're scaling it twice. And you can do it with the mirror tool as well. You can actually take the mirror tool and you can, if you mirror in view and you mirror the object, you'll notice it mirrors over. But if we change up the to world and we mirror this over, it drops it over here. We'll say OK. And then we move over to local space and we mirror it again. Say OK. We've just done exactly the same thing. Identical process, but we've just done it in a little piece of code that you can easily now start writing and using in your tools to be able to flip over matrices. I guess the question is, was that all new to you guys? I see cool in capitals from Mark, so obviously I hit something there that was worthwhile. Not new, Alistair? You know this? Oh, okay. Yeah, it just takes that little light bulb to go off sometimes, eh, Brandon? I get those eureka moments every now and again. Fortunately, it's usually about 4 a.m. when I'm trying to sleep, and it keeps me awake for the rest of the night, and I find myself in front of the computer, blurry-eyed, trying to extrapolate what I dreamt. So that's good to hear. So what we're going to do is we're going to take a quick little break. I think I probably took longer on that than I wanted to, but quite frankly, I think that's a really, really, really important thing to understand. What's amazing is every single 3D app and 2D app you use uses this piece of math here. Okay? It does the exact same thing. You go over to Maya, it's no different. XSI, C4D, it doesn't matter what software you're in, that is being used to handle the objects and how they're manipulated in space. Okay, so every game engine you're using, everything is doing this same thing. So you know the syntax will look different in the different languages, but basically it's all handling the same thing. Once you understand where the concept goes, you can basically do it. We're going to take a quick little break so I can save off my recording, and we'll be back in 5 minutes sort of thing to continue down the next road. Okay, guys? So now we're going to get into taking a look at doing bones and setting up bones and basically starting to build a rig and sort of coding some of this stuff together. Now what's interesting is we're going to take a look at building bones and how many, come on, Esteban, that means, I'm not sure what you mean, Esteban. What we're going to look at is some of the information you've just used is actually used in building bones. How many people had a hard time figuring out how to make bones in MaxScript when you first looked at it? You're like, what in the world? What do you mean Z vector or X vector and whatever else? Exactly. I mean, you're looking at going, what in the world does this mean? So when you look at the bone sys, oops, I don't know where I was just typing, but it wasn't in my MaxScript editor here. Let's see if we can find it in the good old MaxScript help. Somehow I doubt it. Oh, look at that, it came up first. Bone sys interface. So bone sys allows us to be able to create our bones, and what it's looking for are three values to get us started. So bonesys.createBone is a command. We got bonesys.refine and several others. So bonesys.createBone, and if you notice what it's doing is, and back to how the help file works, anytime that we see these greater than less than signs, this is necessary. So basically we have to supply it this value, this one, and this one. And start point, that's easy. That's the position of a bone. So let's just create a bone and sort of discuss where the values come from. I'm going to get rid of our mirrored matrix stuff here. So I've got the bottom bone picked. To understand those values is pretty easy now at this point. What we have is, since you guys have learned all about the matrix, we have the start point. Well, that's pretty easy. That's the position of the bone right down at this end. We have the end point. So where does the bone actually point to? In actual reality, it is the end point. It's doing two things. It's not actually, there's no position there. If I get rid of this bone and delete these ones above, there's no position value there, is there? But it's asking for an end position. Well, what in the world is that for, right? I mean, that doesn't make sense because there's no position value there. Well, now that you know about the transform matrix, what it's actually asking for you is the x vector. Now, what it's asking you for is a non-normalized x vector. Okay, so it's asking you for a position up at this point here. And that position, okay, is essentially the direction that this x points in. It's just stretched way out. It's scaled way, 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 way up here. Okay? And what it does is it turns that into a local x vector and applies that into the matrix to rotate it over. The z that it asks for next, it says, then the z-axis, okay, and this is the direction, the z-axis for the new node as a 0.3. This one's asking for a unit vector. So it's applying it to this vector and setting that matrix value so the direction the z points in and basically determines the twist of the bone around. Okay? So let's actually try and get a couple of those values. First off, where in the world is this endpoint? Well, let's just get it for a second here. So we've got a value that we know was set when I built this. Let's simplify this. Let's call this value, our start point equals, so that's going to be the start of our bone. The end point is going to be 0 in the x. It's going to be, let's move it forward in the y in the scene, which is negative y, so negative 10. And it's going to be up in the z 40 units. Okay, that's going to be our end point. And then we've got the z vector, and that is going to be some value pointing in the z, but it has to be an actual world space. It has to be the direction that it's pointing in world space here. So we're going to get and figure out that. So what we're going to do is we're going to point it along the x. Keep it really, really simple. So this is a vector again. So let's point it along the x with what we know about unit vectors now. Okay, so if we build a bone now and we use our bone sys command, bone sys dot create bone, sten and zv. It's going to error on us because I did something wrong, because I didn't evaluate them, because I'm not that smart. There is our new bone that we just created. It's much bigger than the others, by the way, but that point now is way up here, starting way down at the bottom. Okay, if I change our start position and move it up, run it again, you'll notice our endpoint remains exactly the same. Now what it's doing to get the vector along the x is it's doing just a little bit of simple math. That vector has to be relative to wherever the object starts at. So what really it's doing to be able to apply the vector, because it has to be a unit vector, is it's doing this bit of math. It's saying the end minus the st, which gives us a value, an offset value of where it currently is. So essentially an offset from this 0, 0 as opposed to that 0, 0. and it returns us a value. And then what it says is normalize that vector for me into a unit vector. And there is our 45-degree angle that we currently have on that bone slanted forward. Remember when we rotated something 45 degrees, we got this value? So there's the value that's actually, it normalizes a command that takes a vector and turns it into a unit vector. Basically takes it down so it's 1 unit in length. And you can actually ask length of this vector and it returns 1. If we ask the length of this vector, it's 14. Okay, so we need unit vectors to go into the matrix. So that's what it's doing under the hood. So it's just using the matrix, and it's using this basic mathematics to actually create and build you bones. Understand bone creation a bit more now? And of course, the z vector is the direction the z points in world space. Nice, isn't it? Pretty straightforward. So let's actually do this. We want to start building bones, and generally we want to build bones in very specific locations, right? So we've got, again, a set of bones, and essentially we want to be able to build, let me just zoom in a little closer here. We've gone and created a master rig for a spine or something, okay? And we've said, well, we want to be able to go in and we want to be able to rebuild this. And I don't know how you guys do it, but you probably build it and then go through and try and record all the values and figure out what they all are, and then go and try and actually write it all into your code and hard code your code with all the values, correct? Is that generally what everybody's doing? So let's not do that. Let's do it a little bit smarter, and let's use some of our abilities as coders to inspect what we have and get some code that gets us these values and feeds it back. So what we're going to do is we're going to use a for loop. Anybody in the crowd not done for loops? For x or for I for loops? Speak up right now. Anybody not done a for loop and needs me to explain it? Not. Okay, let me do explanations of for loops and arrays then. So how about arrays then? Okay, let me get into explaining it then. Sorry for you guys who've done it. Sorry, you'll have to hold on. Not. All right, perfect. Then we'll definitely get into it. So what an array is a collection of objects. If I actually grab all of these objects in the scene, that is an array of selected objects. If I check the scene, I have actually an entire scene and an array. So if you think of the array tool in Max, and it makes a whole bunch of objects, okay? And there are a number of predefined arrays in Max. One of them, objects. You'll notice it comes up in italics and whatnot. I'll just clear my listener, and I'll evaluate it, and it returns objects. Now, an array basically is a collection, is an ordered collection in the of something. It doesn't need to be objects. It could be names. It could be values. It could be anything. In this case, objects represents all of the objects in the scene, and it's ordered in a way that basically allows you to be able to go through the order that they are created in the scene. So in any given scene, it has an order based on the creation order. And what we can do is we can check a couple of things. If you look up array properties in MaxScript help, you'll find there's some properties to an array. If I ask for a .count and run it, it basically tells me my scene currently contains 5 objects. So I have 5 things in the scene. Now, if I want to get to the first object in the scene, what I have to do is get it by its index. So it's indexed value, number 1. We do that with this bit of syntax here, using square brackets after it, indicating we want the first object in the scene. Evaluate that, and what it's returning back is bone 001, which is this bone right here. So I could actually do something as simple as say, select, and it selects that bone at the beginning. I could also do, and it'll select all of the objects in the entire scene, okay? And it'll select everything, knowing that those are, that only works, of course, if the array contains objects and not, an aim or a value or something, the select command. So we can get at each one. We can find out what the last one is, 5. And something to note if you come from any other language, MaxScript is 1-based, not 0-based. Every other language you're probably going to touch, arrays start at 0. 0 is the first item in the list, okay? That goes for .NET when you use it in MaxScript. You suddenly have to start thinking about everything's back one, okay? They did it in MaxScript because MaxScript was kind of written for artists, and quite frankly, to me, it makes sense that the first item in the scene is number 1, not 0. But that's the way coding works. So that's an array. We can also get an array of selected objects. Selection returns us an array of selected objects. So I can grab 2 objects, dot count, and find out how many are in there. Where this becomes powerful is the ability to be able to use for loops. And a for loop, the best way to describe it, to students, is like a little engine. Okay, so we're going to build a little motor that's going to do something. So, we've got a, you think about a conveyor belt processing things, right? Where they're making stuff, and they've got this machine and this conveyor belt. It basically goes through and it makes an array of toys by stamping one out after the other, right? And what we're going to do is we're going to make that little machine that's going to use our array as the feeder. Okay, so you've got a hopper full of plastic beads. You've got your machine that's running, and the beads get filed down into the machine out of the hopper, and the machine stamps out little plastic toys for the kids. Okay, so let's write the little machine. For is the key word here. So there's 2 ways of writing a for loop. For I equals 1, 2. We're going to loop through all of the objects in the scene. Oops. So for I equals 1 to objects.count, what this means is this. We're going to make a little variable called I. So I is just a variable. All right? It can be anything. In this case, it's going to be a value that's going to start at 1, and it's going to stop at whatever value this currently returns, and in this case it's going to be 5. Okay, so what we can do is we don't have to predetermine how many times it's going to loop through the scene. We know how many times it's going to loop through the scene because the scene has this objects.count property. We can get everything in the scene. So we don't have to know previously when we write this code how many objects there are in the scene. We can just tell it start at 1, run until you run out of objects. I'm just going to use the print command and say print I. And I'm going to run this little piece of code now. And you'll notice it returns 1, 2, 3, 4, 5. So I has become equal to the values 1, 2, 3, 4, 5. Remember we got access to the indexed items in the array by giving it the index? Well, I is a variable containing that index. So if I run this now, you notice it returns back bono 1, bono 2, 3, 4, 5. So it's running through and it's saying print out the first time it runs, I is equal to 1. It says print objects 1. Goes back to the top, I gets indexed up to 2. Goes down, print objects 2. Goes back to the top, I is indexed to 3. Print objects 3. So it's a little machine that runs over and over and over again and runs through everything. So this actually allows us to be able to go and do something to each one of these objects in an array. Give me the name for each one. Set the name for each one, whatever it might be. Second way to write a for loop . For X in objects do. If you notice, in this case, it prints out the objects. Now, these are 2 very typical array for loop types that you're going to see in languages: indexed and iterative for loops. This one basically comes up with the index. And this one does it a bit differently. It says, this is the array, whatever our array name is. It could be an array that we've made. Okay. And what we're going to do is we're going to say X is going to become equal to each thing in that array, one after the other, print x. So in this case, it becomes equal to the first thing and prints that object that's in there. So the actual item in the array, not its index. Both are useful. This one's sort of cleaner, faster, but not necessarily as useful as this one, because sometimes we want that index. So those are two different array types. So indexed and iterative array types that allow us to be able to go through and use arrays and loop through them all and be able to do things en masse as opposed to having to do things one at a time. You guys have probably been writing code. If you haven't been using arrays, you've been writing one line after another, and you've probably found yourself writing nearly the same line over and over and over and over again. So one of the big rules in code, if you're writing something over again, find a better way. Okay? And so what we're going to do is we're going to actually come up with a little system right off the bat that's going to go and use a for loop, and it's going to use a for loop, and it's going to get us and build us an array. And an array in MaxScript looks like that. That is an array. So if I say my array equals class of my array, it's an array. It has nothing in it, has no parts. Zero. That sticks something in my array. Actually, let's do this. My array now has 4 items in it. They're separated by commas. If I check the count, it's got 4 items. Check the first one, 0. Second one, 10. Third item, 20. Fourth item, 30. Fifth item, doesn't exist, it's undefined. Okay? Does that explain arrays and for loops somewhat? You can see that it makes a little machine we're going to use. So let's go and collect all of the information we need out of this. So what we're going to do is we're going to use a little for loop. Because, I mean, you guys go and sit there and pull this apart. Well, why not write code that helps you determine what you've done and pull apart some of your code? So we'll do it over selection, which is an array, predefined array. And what we're going to do is we're actually going to get it to print out the information for each of these items into what looks like an array. And we're going to use the format command for that. Format instead of print. Format allows you to make some sort of formatting around the things that you're going to print out. Okay? And the formatting comes in the place of quotes. And if we basically say format, I'm just going to run this little piece of code. And you'll notice what it's just done is it said Bono 1, Bono 2, Bono 3, Bono 4, because we have them all selected. And then OK at the end. So the way format works is format anything we want to put inside this formatting here. Okay? And then the %, though, allows us to be able to put a variable in and replace the %. So what we could actually do is we could do something like this. We've just formatted out separate arrays, and each separate array has a different bone name in it. Let's go and add more stuff to the array here. We're going to add our start position, comma, which would have to be in the array, our end position, our Z vector, and the name of the item. So what we need now is we need 4 things here, 4 variables along in our list here to be able to be put in. So what we're going to do is we're going to go x.pause. So x.pos is a short form for getting to the position value, and we're going to get that position value. Now to get the end value, we can do it in multiple different ways. Okay, there's sort of several different ways to do it. One of the ways of get the end value is find out whatever its child's position start value is. That won't work when we get to the end, however, because it has no child. So we're going to have to determine that some other way. But here's a way that basically will get us the. Oops, sorry, I just hit cap locks. I don't mean to yell at you through MaxScript there. And we are going to use row 1. Row 1 is the x vector. So it is a little unit vector that points straight up. We know it's 1 unit in length, correct? So since it's 1 unit in length, we can actually get the length of the bone through its length property. So bones have a length property. Let's multiply that by the length. That'll get us that unit vector, but from 0, because the unit vector basically starts at 0. So it thinks it's back down here. Then all we need to do is get it to determine and add on its offset value from 0, 0, 0 world space, so wherever it is. Because unit vector basically just a little vector that points in a direction. Okay, it doesn't know where it starts. So let's add in the position value of the actual box. So basically what we're doing is we're getting the vector from the transform matrix pointing along its x, multiplying it by its length, so it's got a length probably pointing to about here, and then we're offsetting that value by its current start position. The last value that we're going to look at getting is going to be its z vector. Well, that's a really easy one. Let me roll it over a bit more. Which is the third row in our transform matrix, which is our z. Okay, so you can see why I explained to you how that worked. So if you look at this piece of code now, what it's doing is it's going to format out this information. So let's just clear down here. And what it's done is it's formatted out a whole bunch of information for us in nice formatted arrays. But it's in one line, and it's really, really, really ugly and hard to look at. I'm going to use \n. So when you're dealing with strings, there are escape characters always when you're dealing with strings. And in MaxScript, it's \n or backslash. And a \n means new line. Create me a new line. A \t is create a tab character in here. So you'll have to look up those and sort of dive into those. So if I run this now, it's throwing it onto each new line for me. So I now have an array. Each array contains the start, end, z vector, and name of each bone in my selection. And I'm going to go one step further. I'm just going to stick a little comma on the end here. And you're going to see why I do this in a second. And we can even get into sort of deeper and deeper formatting here. I'm just going to run this. Here's our formatted out information with little commas on the end. I'm going to leave the last comma out. Grab all this chunk of code. Just give myself some space. I'm just going to paste it in there. So what you've got now is you've got separate arrays. Each one of these is an array. And what I'm going to do is let you think about that one for a second. What I've just done with the bones is make an array. I'll just move that up there. There is an array, an empty array called the bones. This array doesn't hold objects. It doesn't hold, does MaxScript throw an error when it's undefined? It'll say undefined. It depends on if you try and say x times undefined, it will then throw an error. Depends what you're doing with the undefined. So what I've just done is made what's called a nested array. It's an array of arrays. Let me just evaluate that and explain it real quick. The bones dot count has got 5 items in it. The bones 1 is an array. So if I actually check that, it's actually an array. So has 4 items in it. So I can actually loop through the bones array, and I can actually use the array information of each one of these as information. Now we have a bit of a problem. See this right here? Notice how when I evaluate this, the names all come up undefined. That's because it doesn't have quotation marks around each one. So we could go through the process of throwing quotes around it, or we could doctor a little piece of code here and say, and here's the neat one, inside of a string, we can't just add more quotes. This last one here, this last one here represents our name. We can't just throw quote marks in there. What we have to do is use our escape character again. So escape quote is a quotation mark. So again, I'm just going to clear this, everything picked, remake that. Tab it in one. And now you'll see that what we've got is proper name values with quotations around it. So using that escape character, it's basically saying this is a quote. So print a quote out inside of this formatted string. So what we can do now is we can go ahead and build a little engine to build all of our bones instead of having to do them one line at a time. We can do this in a very, very fast and efficient way now, as opposed to probably what most of you guys have been doing, I would assume at this point, unless you're doing this, is building a little engine that's going to go and do what we need it to do. So we're going to use an index for loop in this case. 1, 2. 1 to what? So let's loop through all of the items in the bones. So here's our hopper full of items. There's 5 items in our hopper. Interesting thing about this one is each item is a hopper full of items. And we could say print the bones I 1. And what it's done is it's printed out the start value of each one of the bones, because it's gone in and iterated through each one of these arrays. So there is item number 1, item number 2, item number 3, item 4, item 5, and that's I. And then we're asking for the first item. If this was 1, we're asking for the first item in number 1, first item in number 2, and down through the system basically. So let's do this. Let's go and make it actually create a bone. I'm going to make a little variable. And what we're going to do is then we're going to have to pass it the values that are necessary. So each one of these is going to have to be passed one after the other. So we only need those 3. And so first item in the array, start position, second item, end position, third item, Z vector. Can't set the name while you're making it. Set the name on the item. I'm just going to move this over. Make sure we've evaluated our bone array. Run our for loop and get an error. What did I miss? Call needs bones says, oh, dot create bone. Oops. So even I make errors. Sorry, guys. Hoi. Looks like I've got my math in there wrong somewhere for the end positions. Not quite sure why. Oh, shoot. Add the position, don't multiply it. Paul, sorry guys. Try and talk, and again, it's that old bubblegum thing. Sorry about that. Let me rerun that and go and get my code again. Go and get my array. So sorry, I'm supposed to add the position, not multiply it in. Didn't have anything picked. Pick them in order. I'll just grab them this way and get rid of that last. Don't want this last comma here because there's nothing after it, right? Reevaluate that. Just move these out of the way. Rerun. There's an exact duplicate of what we captured. That's going to make your life a lot easier. Now the problem with this is it's not linked together. Okay? There's no hierarchy here. We didn't tell it to hierarchically put it together, but we created each of the bones in their correct positions. So what we need to do is we need to go and link them together. Now what we want to make sure we do is, and this is the reason I used an indexed loop, we want to parent each one as it goes, but we can't parent the first one to anything because there is nothing to parent to. So we want to say with an if statement, if I is greater than 1, so if it's greater than it, do, so hopefully you're using your if statements. So we're going to ask the question, if I is greater than 1, that means that we've already made our first bone, okay? Then let's go ahead and start doing some parenting and parent from there. Now, what are we going to parent to, though? Because every time we make a new bone, B is being overwritten. We haven't held on to what we want to parent to. So let's do a little quick thing. Let's collect the bones as we make them. So we're going to make a new little variable called the bones. And we're going to collect them as we go. And to build an array and add items to array, you use an append command. Append to what? The bones. Okay. And what are we going to add to the bones? The bone that we make. Fair enough? So every single time a bone is made right now, it's going to make a bone. It's going to use values that we've stored in our array. It's going to name the bone. We'll just ignore this for the moment. Then it's going to append the bone to this bone array, and this bone array is going to get longer and longer and bigger as it grows. So if it's gone through and I is now equal to 2, it should have already appended a bone to this list. So what we're going to do is we're going to set the parent of b dot parent equals, and what does it equal? It equals whatever the last item that was put into this array. And how do you know what the last item is? So how do you get to it? Well, newBones.count returns to you the index of the last item. So I can just use my quick, that's that, see how that blue keeps coming up there with the last thing typed? That's what's happening through my user properties. newBones.count will return the last one to me each time, right? So this is a nice little machine now that's going to go ahead and it's actually going to build all my bones and link them all together for me. Does that all make sense? And how new was this to everybody? The idea is not writing out one line at a time. If you find yourself writing something one line at a time and rewriting the same thing with only slight differences to it, you can create a for loop and pass it variables that will do that. Yeah, Python has the same commands like that. I mean, most languages do. Printf is used, and different syntax for it, but essentially the same thing. Yeah, fair enough. Okay, so the idea being is that what we can do is we can create a little machine to do the work for us. Instead of, in the old days, they used to make one car at a time. Each piece would get built by hand, one piece at a time, and all the pieces ended up a little bit different. And if they needed to go back and fix a part of a car, they had a problem because they couldn't put a standard part in that car because there were no standard parts. And so maintaining the cars became a problem. Henry Ford came along and said, wait a minute, what about a machine that makes our car parts so that all of the car parts are identical? So that when we need to fix a car, we can drop one of the identical parts in the car. And essentially what this becomes is manageable code now. We've got a piece of code here. So essentially this for loop and this chunk here that can make any amount of bones for us, as opposed to what you're probably doing is rewriting bone sys create bone, sending it a bunch of values, right? We've created a for loop here that'll grab the bone values from any amount of bones that we grab in a hierarchy and run it on. Okay, so this plus this equals much faster, much cleaner, much more maintainable code, because if we have a problem in the creation of our code, it's right here. If we have a problem in the values of the code, it's all contained here. And where are we at? We're at another hour. Oh no, I've got 38 minutes on my capture clock here, so we'll keep going a little bit. I minus 1. Yes. Yeah, you could probably, yeah, exactly. Yeah, you could probably do the same thing. Correct, you could do the same thing there. Yeah, that would work too. Because I is giving that index. So either way, you got to be careful in this sort of, sort of concern that your indexes are matched up that way. But yes, Tong, that would do the exact same thing, because we know that this amount of new bones we've generated is always one less than the index we're currently working on. Correct. Either way. So again, it's one of those things. There's multiple ways to write something. A lot of the times, it's what makes the most sense to you. And again, is the most readable. I write my code really readable. I don't try and taper it down to the least amount of lines and the least amount of white space. That's a bad habit to get into. You can't read it, and you can't read somebody else's code that's done that. Comment like crazy. You should have comments above everything that have some sort of definable comment here, and state, okay, here's a comment, and there's my quick hotkey for my comment start ends that I put in and whatnot. You should have comments inside. If you've sort of written something, add a comment here, dash dash. This is how it's one of those funky ways you've got around something. Comment the fact that new bones I minus 1 represents, and the newer you are, the more comments you should be adding, because the more you can go back and rip apart your code later. Now, what we want to get into is adding an IK solver, which is pretty straightforward. I don't know if you guys have taken a look at doing it, but it's pretty straightforward. There's another IK sys this time. IK sys. I have to think about this. .ik chain, I believe. Yes, that's right. Comes up in blue. Look up the IK sys commands, and you can find what you can do with it. And the IKsys.ik chain command is looking for the start bone, end bone, and then the type of solver. And the type of solver is a bit of a pain. If you look up in the help, it actually doesn't tell you what the different names are, which is really silly necessarily, but you can get them by creating them and asking for what its name is. And because it has to be passed as a string. So in this case, what we want to do is we want to actually use our bone array, okay, and just use the bones that we know have been put into it. So if this was going to be a one chain that was going to have a solver on it, the first bone is the one that we're going to start with. The last bone is going to be the last one. And the string that's going to represent the IK high solver, which would be the one you'd normally use, should be IK high solver. I don't believe it's case dependent either. And if I run that line now, it's going to add an IK solver between them all. So basically it's asking for the start, end, and the name of the solver. And let's just do, let's see if we can just find this quickly. If you ask for solver name, and then the index solver in the scene, what you can do is you can go around, just make some solvers, and go back and it'll return the names that you need to use to place this. Okay, why it was done that way, I don't know, but quite frankly, it's a little messy. And I wish they'd just list all of them here. I guess they do. They list 3 here, so there you go. So there's the 3 that are in the scene. So they need to be supplied as a string, so inside of quotes. So you can just cut and paste those now. It's good they've added this because I don't think that was there before. And other commands that you can use with the IK solvers. So adding a solver is pretty straightforward, and dropping that in. And of course, parenting is just whatever the item is. And this again also returns the item. So we can say IK, solver equals, and it'll return the item, and then we can find parent objects for those. So the thing is that building code that builds rigs is going to be fairly linear. But we can start breaking down chunks that we keep doing over and over and over and over again into for loops. And let's get into the next stage. Let's actually start breaking that down into functions, and then breaking that down into nice code structure. Okay, so we're going to try and cover that really quick. I'm going to take another quick break for a drink of water and to make sure I stop my capture and grab it here. And so I'll be back in a second again, okay? Okay, so welcome back. I assume everybody can still see my screen and hear me okay. Just confirm that, somebody for me. Yeah, all right, good. So let's start making some better code, okay? What we're writing here is still sloppy in that we've got this, right now it's obviously a complete mess because we're doing a lot of test code, but even if we are writing a script, we've got these arrays hanging out here, and we've got these for loops hanging out here. What I mean by hanging out here is this array right now is what's called a global variable array. So it's globally accessible in MaxScript. It means from anywhere in MaxScript, any other script is seeing this variable. And if some other script that you've written happens to use a variable called the bones, it just overwrote your global variable. And now you're going to go back to hitting the next button, and this thing's going to blow up on you because the bones now doesn't happen to contain a list of bone values, 0.3 values and whatnot. It happens to contain a bunch of objects. So the having everything globally accessible is a problem we're going to try and address, as well as we've got this problem that we're writing this for loop here that is directly accessing this one variable for creating our bones. Well, this is still sloppy in the fact that we're going to have to keep rewriting this for loop. You're going to be going down, you copy and paste this for loop and change the bones into the arm bones and the leg bones, and so you're going to have the same for loop written over and over and over again. So you have to stop yourself and say, is there a better way? You should never be writing code that's very similar twice. You should be trying to find some way of passing variables to it that actually make the code more multi-purpose. So you're going to write a character. You're going to write a character creation script that's going to have this in there 100 times for creating a biped, and then you're going to go want to do one for a character that's creating a quadruped, and you're going to write it all over again, and then you're going to write another one. So let's not do that. Let's take a look right off the bat. I'm going to start with a new script. We're going to take a look at functions. So functions, there's the full name for a function. Sorry, when you want to write a function. The short form is just, in MaxScript, fn will get you the same thing, okay? So it's one and the same. Now what a function is a way to create a reusable chunk of code. Function, let's do one, test equals print test. If I evaluate this piece of code, I'm just going to go and clear down here and evaluate this. I'm just going to use Control E for the evaluate everything. And what it does, it returns the function itself. To call the function is exactly what was printed out to the listener. We call the function now. So this has been actually created somewhere in our code, and this is maybe being called when we push a button. And I'll evaluate that, and you'll see it runs test. Now it's printing test twice for two reasons. One, it's printing test because I said print test. And two, the function actually returns a value. The last line of the function is returned back to and can be used as a variable. So if I use str as string, we'll just rerun all this. You'll notice now that it's printed it twice again. If I check the value of string, it's test. So it's actually returned that back out to, and the function is actually returned a value. Okay, so big deal. I could have just said print test. I would have got the same thing here. Well, let's call there's our function. Evaluates fine. We're going to run it, and we get an error. It says augment count error. Test wanted 1 got 0. How many times have you guys seen that in your code when you're trying to use code along the ways? So what it's saying is that the test function requires one parameter to be passed to it. When I'm using it right now, I'm actually not passing any parameters. Like when you make a box, okay, as opposed to making a box and passing it some variable name. Or a position or something. So what we need to do now is pass it and if we run this again, you'll notice that, let me just run that. Some name value is what's being printed here. So this becomes a variable I can use in this reusable chunk of code. So you can see that I can pass it variables. And of course that variable doesn't have to be a string. It could be an array. It could be a float value. It could be whatever. Obviously I have to be using it in the right way in here. So what we're going to do is we're going to use this idea of creating a function to be able to reuse our bone creation code and set that up. So let's go function create bones, bone array, and it was in here. So let's go get our bone array. I'm just going to do some cut and paste here. I'm just going to go get our bone array because we'll need this. And let's go and get our piece of code that actually did all the work. And I want to put that inside the function this time. Okay, so you can see it's actually going inside. Whoops, I need the whole for loop. What am I doing? Sorry, I need the whole for loop. My bad, and you'll see where I'm going in 1 second. Don't worry, I'll explain this. And we also need our array where we're collecting everything. Okay, so here's what we have now. We have, I'm going to get rid of this top piece. Here's a bit better script here. Bone array, again, real quick, that made the bone array. There it is there. So, got to keep going though. So here's a script now that lists an array. Maybe this is spine. Spine bones. So this is our sort of captured chunk of spine bones. New bones. Now if you notice in our for loop here, what we're doing is we're working with and we're calling on that the bones that we defined as an array previously as a specific name, a specific variable. We don't want that. We're actually going to use this variable here instead. So we're actually going to, maybe I could just, yeah, clarity, I'll use this. So I'll call it B arrays for bone array. So this is going to be a variable that we can pass to it. We can pass to it any array of data that looks like this. So what I would have to do is I would have to change up all of my code here. Kind of the slow way of doing it, but just for clarity. So I replaced that specific bone array with our variable name here now that we're going to be passing to it. So I should be able to run this chunk of code and get no errors in our create bones function. And to create the bones function now, we're going to call the create bones function, and we're going to pass it the array that we want to use. So what we have now is more reusable code. We have basically a chunk of code. We'd have multiple ones of these: spine, arm, legs. But we have this reusable chunk of code that goes ahead and builds the hierarchy of bones for us based on this data set that's passed into it. So again, as far as cleanliness goes, all we have to be doing is capturing this from now on, adding it in, and then adding in lines to be able to fire them off. So if we actually evaluate this whole chunk of code, there's our bone chain back again. We want to build it again. All we have to do is fire this one line. There's another bone chain exactly the same again. Okay, so the idea being is this could be housed in a script, and from any of our scripts now, we just keep calling the same function. So we have one script that basically has reusable chunks of code in it, and we have other scripts that call on those and actually allow us to apply those values to it. Okay, and in actual fact, I get even fancier. I store this sort of information in XML files. So I don't actually have it hard-coded into a script. It's actually coded into an XML file, and that XML file is just a data file about what the rig looks like. We're not getting into that today, by the way. So what we want to do is we want to clean this up a little bit more yet. We don't have a proper tool, and writing a nice tool to be able to build stuff around in ways of sort of containing things. This is still a global variable. Create bones function is a global variable, okay? And we're calling this globally. Accessible anywhere from any script, all of the time. Anything can write over stuff. So what we want to do is we want to make a container, and a container that we can put stuff in. And one of the ways to do it is with structures. Structures are used for two things. One, making containers like I'm about to, sort of thing, for tools. And two, for containing, call it named data. So sort of like an array, but each item in the array has a name that you can access the item instead of by index. We're not going to get into that probably much today. We're just not going to have time. But I'll show you how I use structures and how I write my tools. So I'm going to go start another script again. And I want to start a struct this time. And again, like I said, a struct can be something that contains named values. Variable 1, comma, variable 2. Run that, creates a variable. What I can do then is make a reference, or a sort of a reference to that. I have to create a reference, and I'm just going to overwrite the same name. I'll explain that in a minute. You actually have to create those to be able to access it. And I can assign data now to test. Let's actually not do that. Let's just do it. Let's do it so it makes more sense to you. There's my structure. I want to make a reference to it. So there it is, a copy of it. And I can say dot var 1 equals 1. A dot var, oops, next line, Paul. A dot var, or var 2 equals 2. Print A again. Notice that we actually have var 1, var 2, and they have values now instead of just undefined. So I can say A dot var 1, and it returns the value 1 to us. So call it a more ordered array, in that we can actually have named properties to the items that we are containing. This is a great way of storing data, but the way we're going to use it is we're actually going to make a tool out of it, and we're going to set up a tool for it, and we're going to use it a way to actually store a tool. Now what I use is I use a nasty long variable name here that because this is going to sit globally. Everything else inside it is going to be local, meaning that anything inside it is being protected by my rigging tool. Now make sure this is a nice big name that you're not likely going to overwrite accidentally with some other tool that you've written. To make this structure valid, again, I'm going to go ahead and make an instance, sorry, not a reference, an instance to it. And I have to make an instance. And I'm going to just overwrite the same name. So believe it or not, there is a variable, and because there's nothing in it, it throws an error to me. I need to start adding stuff. Structures don't just have to contain data, like our values that we were passing there, 1 and 2. We can actually put functions in them. We can do all kinds of things. So we can stick other types of arrays into them. So what we're going to do is we're going to start building data inside here that's protected. So here is a structure now, and this structure happens to contain one variable. It's an array that contains arrays, okay? And now we want another item. And if you notice before when I separated the items, just like an array, I separate them with a comma. Stick a comma after each item that's going into our structure. Our next structure is going to be our function that creates bones. So if I fire that off now, we've got this nice structure. If I actually go and check on these variable names, let's actually just do something here. I'm going to say create bones 2, for instance, because the other one was already made global. So I'm going to make a new variable name here. Create bones 2 and run that. And if I actually check that variable, it's undefined. Even though I just evaluated the code, it's undefined. The other one is global. The first one that we were working with in the other scripts is global and it's accessible by anywhere. This one's not seen, and the only way you can get at this now is through our instance of our structure. So my rigging tools.createBones, oh, sorry, something is erroring. Unknown property create bones. Oh, 2. Sorry. There we go. Our create bones 2 is contained inside of this set of brackets. Therefore, it's local to my tool, but I can access it from outside because all I have to do is go through the instance that I made of it, and I can get at it. So my rigging tools dot create bones. I could say my rigging tools dot spine bones. They're all there, and they're contained inside. So I can contain everything inside of this tool, which makes it really, really nice because I can actually have one structure, not even have this inside it, for instance, and just have one structure that does nothing but have reusable functions that I'm going to call from my individual rigging tool parts that are going to make my arm, make my leg, make my whatever. So it's going to generate inside of here those individual pieces. You guys following this? Everybody else good? This is getting a little bit advanced, but the idea is I want to take you down the roads that you should be looking at. Cleaning up and making your code cleaner and better and less likely and less prone to error. Okay, so now what we can do is we can start building a tool around this. We're going to keep it all contained in one structure. I have mine in multiple. I have a structure of nothing but reusable functions and other structures that have the individual nitty-gritty parts of building the rig that does the specifics to the rig. But I have things like a create bones function that does, it's far more complex than this because it handles branching data sets and whatnot, branching hierarchies and naming and everything else. So it gets further and further in depth than this one does. So the idea being is we can then go and actually create rollout, say, inside here, and we'll stick it inside another function. Notice I put a comma. I assume everybody's made a rollout. You can tell I use test a lot for training. Oops. Run the function. And there's my UI. But again, this UI is being run, and I have the feeling, oh, it seems my recording, sorry. I'm wondering if my, can you guys still hear me okay? Give me a yes or no. Yes, okay, good. Something just went off my screen for some reason on the other side, and I didn't know why it was. I think I just hotkeyed something. There's my backup batch file. Okay, so yeah, something just flicked off. Okay, I'll just keep going. And I'm going to add a button, and it's going to be BT for button. I always add. Create spine, run that. There's my create spine tool. And again, I assume you guys have gone through and done rollouts. I'll explain them a little bit. This is just a container again. It's actually much like the structure, but it is allowed to contain things like buttons and UI items, and of course, event handlers. So creating buttons, if you haven't done it, is there anybody here that's not created UI items? Speak up now. I'm sort of feeling that this crowd is a little more advanced, and I don't need to cover this. Anybody not created UI items? Okay, so there's your button, you know, internal name, external name for the end user, and an event handle. So on create spine BT press do, we're going to run it and do something with it. Now what we want to do is we want to call our function, and we want to pass it our spine bones. Fair enough. So we've got a rollout with a button, and when we press the button, we're going to call our function, and we're going to create this. So watch what happens. Error. Okay. So here's what happens. Struct member access requires instance create bones 2. So what's happened is this. Scope. Scope is the terminology used when you're talking about a variable being global or local. Okay? So the scope, in this case, of UI function is local to my rigging tool structure. So I have to go through my rigging tool structure .ui to get to it. If I just if it just called this function, I'd get an error again saying the same thing. It can't, I don't know what it is, because UI is undefined globally. Doesn't exist globally, so therefore it just comes up undefined. So I have to go through this path to get to it. Now the interesting thing about rollouts is they kind of exist in their own scope, and they are all pretty much always sort of global, kind of. They've got their own scope idea. As soon as we launch this rollout, even though we've launched it locally inside of our tool, and locally basically this can see that, okay, our function can see this, you know, the things that are inside it. So anything sort of inside this structure can see everything else inside the structure. This can't, and the reason it can't is the rollout's got its own scope, and as soon as we create a dialog, it now sits outside of our structure. So what we want to do is we always want to use our access via our global variable that we've created for our instance of our structure. So I have to go back into my structure to be able to get that bone system to work. So now when I run it, struct member still errors. And I know why, sorry, because I'm being a fool. Not only do I have to access create bones to function, I have to create an access the variable that I'm passing to it as well. Okay, and I have to access it because it sits outside of it as well. Run it again, and there's our bone system. Looks a little more long-winded, but it's very safe now. It's very clean. Other tools can't overwrite it. And now we could actually have two structures, one that contains UIs and separate individual items and pieces of our specific rigging, and then other structures that contain things like useful, repurposable, reusable functions that are going to be used all the time. Renaming tools, for instance, our mirroring functions for mirroring bones from left to right, tools for creating control objects, nice spline control objects like all my drag and drop ones and whatnot. Tools for doing very specific things. And then we go to write the next script piece. Once we've got all that reusable code out of the way, as we start writing new elements and new pieces and new rigs, what we're doing is we're not rewriting code all the time. We're just calling functions. Okay, so I need the make an arm. Let's make an arm. Let's use my capture. So my rigging tool dot capture bones, and it spits out an array for me that I cut and paste into my other script. Now let's add into that to create it. So my rigging tool dot create bones, pass it the array that I've made. So it's one of these things where I'm reusing bits of code over and over and over and over so that we're not rewriting things. And your ability to develop tools will increase rapidly because you're all of a sudden finding yourself pulling on things. For instance, mirroring code for me doesn't go in my rigging tools script. It goes into a math library script. So I have a structure that is nothing but advanced math stuff that's not being, there's no functions for it directly in MaxScript. And I've written my own ones. So what I've got is I've got this structure script that basically is a structure and then an instance of the structure being made, and it sits in the plugins directory in Max. So as soon as you start Max, my math library is loaded into Max. And essentially any script that needs to call it now can call it. It just grabs that math library and goes in and calls it. So it becomes much cleaner and much more reusable. And that is sort of the whole goal of this this masterclass, is to looking at taking to the next step and not writing your typical linear mess. Okay? How many people are now looking at their own code going, oh my God, don't show it to Paul, it's a linear mess of just one line after the other. Guilty, yeah. Well, so am I, okay? So, yeah. I'm sure everybody is. Okay, so here's the next level. Let's start making it clean and neat and tidy and thinking about reuse. So every time you go to rewrite something, and it's basically exactly the same as the last line you wrote with a variable change, let's turn that into a for loop. Let's turn it into a function. Let's contain it inside of a structure. And let's build ourselves a library of tools and stuff that'll actually be able to carry it forward, right? Much, much cleaner. So a few other things. We didn't get to controllers and whatnot. Being able to add controllers and build controllers. So I'm running out of time fast here, but so let me zip through a few things. One of the other things that probably should go inside of our structure is a function for I'll stick a comma after it because I've got a function that comes after it. The last one in the structure doesn't get one. So here's one of the things that I have inside of mine is some sort of freeze transform tool. We're going to get it to do the exact same thing that basically this freeze transform does here. Okay. Now there's two functions I write here. One is a reset transform that blows out all controllers and resets them, and one that freezes them because when you ask MaxScript to freeze transforms on an item, it says it's going to be rebuilding it. So it resets it and then rebuilds it again. And so we're going to say reset on what? On an object we're going to pass it. So here's two tools. So how are we going to do this? We're going to say reset these controls. Now let's do it a little bit better. Let's actually have it so we can pass it an array. I'm going to change the variable names to objects. Now there's two ways we could do it. Take a look if you want to advance yourself. Mapped functions. I won't get into it today though, but if you think yourself a little more advanced, look up mapped functions. It does an array for you. So we're going to say that's an array, and we're going to say for x in OBJs, because that's our array, do. I'm going to reset the controllers now, and we're going to reset them to something. So we're going to say x dot pause dot controller equals, and that's a position XYZ controller. And that's an Euler XYZ controller. So there's our reset function. Mine's a little more advanced than that. It takes more things into considerations. Issues and bugs in Max. If you reset a controller like this and there's a constraint on it, the object won't stay put. So what I do is I grab the transform matrix. And I reset it. Because what will happen is it'll jump. So I'll do a real cheat. Grab the transform matrix before you reset it, reset the controllers, and then force the old transform matrix back into it, and it looks like it all stays put. Freezing transform now is you have to start making list controllers. And list controllers are an array of controllers. So they're just an array again. We can array through them. So we can call it plist position list. Creates a position list controller, and we can inspect those and take a look in the help as to how to access it. plist.available will give you the available controller. Available controller. So if when you look at a list controller, you've got an available slot. You can add another controller in there. It will add that to you. What we want to do is we actually want to set it to be another positional list. We can actually tell it to do things like set active and set which controller to be active in this list. Now, we're going to go and take our objects here, and we're going to loop through these again. So let's write this properly. For x in OBJs do. Sorry, I'm really flying now to try and get our time up here, but I think you guys are starting to see where I'm going with all this. Position list. X dot pause dot controller equals plist. plist.available. It's interesting, when you add a list controller, you'll notice it always retains the original controller that's on it. So that one becomes the first one, and there's an available slot that's actually the second one. So we don't have to make both. And then I want to say set active plist 1 or 2. I think that's the order, if right. And I can even name them, and there's set name, and you can set the name on each of them, and set the name of the controller. So we can build ourselves basically a freeze transform. Now, before the frozen transform happens, what I want to do is I want to make sure that my controller gets reset. So all I'm going to do here is I'm going to make sure it gets reset. And I can say reset controllers and reset them, or I can call it when I hit the button for a reset and make sure I reset them first, and then go ahead and freeze transforms on them. So the idea being is these become reusable chunks of code that we can call, and from now on, it's, when you're doing freeze transform, all you got to do is say, well, okay, in my code I got to freeze transforms on this. My rigging tool dot reset controllers, pass it all of the objects currently selected in the scene or an array that you've created, and then say my rigging tool dot freeze transforms, pass it the same array, freeze transform on all of them, and it goes through this list. So we'd have to do the freeze transform with position lists, rotation lists, and set all the set the correct ones active, second ones active, and then of course also set names on them so that they've got decent naming conventions in them as well, and look up the set name in list controllers. So again, the idea is reusable, repurposable code. Okay, so once this is done, once I've hit down here and built this, I could have gone and done something like as simple as my rigging tools, and this variable is being lost in here. That's actually being lost. New bones, append new bones. Let's make sure. Let's do it up in here. Because we're back inside, we're out of the rollout, we're back inside our structure. I don't need to use the instance, so I could do it right here. I could say these new bones, freeze transforms on them. So I can say freeze transform what? New bones. And I want to do a reset on them first, just in case. On what? Oops. On my new bones. So my code might start looking something like that now. So you can see where the code becomes clean. Every time I need to do something, it's really fast and easy to do it. I also break it up. I mean, I could have made my create bones, do a create bones, and then do a reset transform, and then do a freeze transform, all inside the one function. Here's another thing to remember. Don't do that. Every time you see a chunk of code that tends to be a unique piece, produces a unique solution to something, has a unique function, considered as a new little machine that goes into its own function. Because again, we'd suddenly be in a position where we wanted to freeze transforms and we'd be rewriting that chunk of code inside of some other function. Well, let's break out. When you start writing, I'll often do it. I'll be writing a function and the function starts getting big. And I suddenly realize I'm writing something into that function that could be a function itself. So I'll break that chunk out into a new function, something that I could use elsewhere, and just call it from that function. So I've got functions, calling functions, calling functions, calling functions, all the way down the list. And that will again speed up and make things clean. If I have a problem with my freeze transform code, there's only one place that freeze transform code exists. Right there. If I fix it there, I just fixed it for every single one of my tools. Okay? As opposed to having to fix it in 20 different places, or writing it differently in each one and suddenly realizing that my freeze transform is actually working differently in all 10 different character rigging scripts I've got. Wouldn't be a good idea. Does that make sense, guys? The only thing, I haven't got to two things right now. Recursive functions, let me try and explain them. And it's going to be too big to get into heavily here, unfortunately. I just ran out of time, but I'm hoping you guys would agree. I think you've probably got your money's worth at this point. Flagging objects. Let me just talk about flagging objects. I store data in objects to be able to go back and know what I did with them and why I put them there, or what their purpose is in a rig. And there's three ways you can do it. Stick a custom attribute on the object and store data in the custom attribute. Use app data. So if I actually say set app data $sign for the current object I picked, the index, I can't remember, 65,000 channels or something, and then some string, always is a string. I just set and stored that information inside of that bone. I can go back in, I can say get app data from what current item I have picked. I'm doing the cheating bad way you're not supposed to do. From which indexed channel, number one, go and get that something I'm storing. So I've actually stored that string in that object permanently. Wherever that bone goes, it's going to have that information in it. So you can actually store data inside of objects. You can also do it with the user properties, and I'll let you look that up. But if you look at object properties, user-defined properties, there's a whole set of functions for actually adding and removing and reading data out of this user-defined properties channel. So that's another place you can store things, as well as actually being able to put custom attributes on bones and storing stuff that way, which I also do. Now, really quickly, let's talk about branching hierarchies and how you deal with those. I'm just going to create a branching hierarchy here. I'll just rotate that out. Link that into this one, let's say. So you can see that it's pulling that one around. Let's just create another bone here. That'll be linked into there. And this bone, let's grab this whole chain. Actually, let me just unlink it for a second. Just creating a hierarchy. Can you guys still hear me? I'm getting connection difficulty here. Okay. Alrighty. So what I've got is a branching hierarchy. So the hierarchy goes up the center, but it also branches out in different directions. Well, how in the world do you read that? How do you go through and track that down? Everything has it's an array of objects, basically. So the array is this. We're going to say we're going to grab the first object here, $.children. So every object has a .children property, and that children is an array. So if you check the children for this first bone, it actually has two, the one above it and the second one we added, 08. If I go down and I grab the first one, okay, so the first one in the hierarchy, and check that, guess what? It goes down, it has .children. It's only got one in it. Check the children. Let's go into that one. .children. It has one in it. Where did I link you up to? Oh, I didn't link it up. That's why it's not showing. Sorry, it should show 2 now. It's got 2 now because it goes up and it splits off here. It has this one and this one. Let's go into number 2 this time. It has 1 bone in the array. So you can see where that's going to be a problem if you don't know how many children and you don't know how the structure is. How in the world are you going to go through all of that and, let's say, print out the name for each of the bones in your hierarchy of an entire character? How are you going to go through it when you don't know what the hierarchy is? So you can have code that just simply doesn't know what the hierarchy is and able to run down the entire hierarchy. The only way you can do that is with what's called a recursive function. And a recursive function is a function that calls itself. Recurse object obj. So here's a recursive function. It's not recursing yet. And I'm going to pass it the first the object I've got picked and just do this down and dirty. So I've got this first root bone picked. It'll go through and it'll print that bone out. But I want it to go through and print every single bone downstream in order of the hierarchies. So what I'm going to do is I'm going to say for obj dot children do there are all the bones. Let me run that again. There's all the bones in their hierarchical order. 1, 2, 3, 4, 5, 6, 7, 8. Looks like we're missing some again. Did I not? No, put them in. Did I have that one picked? Yeah, spitting them all out. So what it's doing is this. A recursive function basically says, I'm going to recurse through and I'm going to get an object passed to it. Then I'm going to do something with that object, whatever that object might be. Okay, so whatever that thing is that we're going to do to it. So I want to do something each one. So let's say print obj dot name. Okay. And there's the name of our bones. Okay, in all their glory. I don't think this is actually linked to anything. Oh, it is. Okay. What it's doing then is it's going through, gets an object passed to it, one object, which is our root object. It prints out or does something to it. It might be a bunch of operations that it does to it. You know, a bunch of things. It might call a bunch of other functions here. It then loops through all of the children. It says for x in objects.children, which is that produces an array, do call the function and this time pass x in as the object. So right now, let's look at it this way. What's happened is when we first call it, the function runs. It's still running. It prints out the name of the first object we picked. It starts looping through. It gets to the first child. It calls the function. So the first function is still running. A second iteration of this function is now running with the second object passed to it. It prints out its name, and it runs through all of its children. And when it gets and finds out it's got children, it goes into its first child. It calls it again. We have a third iteration of this function running now. And it keeps doing this one after the other until it runs out of items to do. It just keeps going through them. So it wouldn't matter how deep this hierarchy is, this would just keep spitting out the names of every single object in that hierarchy until it got to the end, starting from the root all the way down to the end children. Now you can get it to work in different orders by simply doing this. This will print it out in a different order from last to first, because it's doing it in the opposite order. It basically goes in, loops, calls the function, doesn't get to the print function. Loops through, goes to the next child, goes to the next child, goes to the next child, until that function runs out of children. It says, okay, print. That function ends. The previous function's still running. Checks the next child, checks the next, runs out of things to do, prints that, and it goes down. So you can actually reverse the order in which it actually goes through the hierarchy. Start at my children and come back down, basically, and do your thing by always starting at the root. Okay? So it'll actually traverse it in reverse, in a sense, from top to bottom instead of bottom to top. Okay? So there's a recursive function, and this you're going to need for sure. As you're doing things. You know, another use for this is, let's say you're writing a tool that's going ahead and manipulating directory structures on your hard drives. Well, that is a tree of directories. Well, you can use getdir and getfile and whatnot and be able to loop through all of the directory structures, you know, in your entire system. So very easy to write a function like this that would print out every single file in your entire computer, okay, in a given drive. Very, very quickly and easily. Let me just do a quick save of my recording, and I'll come back for some questions. Okay, guys? Okay, back for a question and answer period. If you can hear me, I'll just let you guys fire them off, basically. I mean, so for everything we've done here, or any question around this topic, you know, fire away. We've got about 15 minutes left to be able to get in some specific questions now about things, and anything you'd like to sort of just point out, recover, or again, extended questions on the same topic line. Fire away, guys. First come, first serve. In line 1, how can that be put in an array? Line 1, this top one, it can't. It is an array. That doesn't need to go in an array. This is what this function does. If you notice, we're going down branches of trees here, but we don't know how many branches of the tree to go down in any given stage of the way. That's what this does. It does this for us, and it knows how many branches, it checks which branches, and it goes down all of the branches all of the time. Come on, guys. Gotta have questions. Whether it be just clarifications on things. No, no, that's the whole point. Ask things that you just not clear on. I don't care if it's been answered or not. You need to get clarifications on things. This is where to do it. So Tong, sorry, you got the first one. Is there a mechanism in MaxScript that doesn't care about order? Um, in what sense, Tong? I mean, doesn't care about what order are you talking about? Arrays always have an order. The scene has to have an order. There simply has to be an order. And if you consider the whole, how in the world would Max know what to do and how to work if there wasn't order? So there is always order. There's an arrays inside of arrays inside of arrays of everything. Your modifier stack is an array of modifiers in order from top to bottom. The objects in the scene, whatever it might be, everything has to have order, or else code simply has no idea. If you want it unordered, then what you can do is you can write yourself a function that scrambles it. So, hey, I want an unordered array of nodes in the scene. Well, then you'd have to write something that would scramble them and rebuild an array that was unordered. Does that answer your question, Tom? Yeah, such as set in some other languages to compare overlapping and something. Not sure, Tong, what you're asking there. Let me move on to Carlos's though. I'm not sure what you're asking, Tong. You're looking for overlapping objects and whatnot, then you still have to do it in an ordered fashion. Sure, something's not already answered before, but how do you get the position of a vertex in a NURBS curve? Oh God, NURBS curves? I haven't looked at that one in a long time. It would probably be, I think, if I remember rightly, the NURBS curve dot num knot. It will get you the number of knots, and then you have to use probably something like a get position. I'd have to look that one up. It's got to be in the help file though, so if you look it up, you'll see that there's variables for that sort of thing. Let me try and get that as we go. See if I can come back to it as I answer other things. NURBS surface, NURBS loft, NURBS blend, NURBS rail, NURBS curve. NURBS curve, get object, NURBS set, because there can be many curves inside of a curve. So you need to know it. Num knots, how about that? I was right, I haven't used this in about 15 years. Num CVs, transform for the curve. There's got to be a get knot. Get and set the index knots value. So that'll be get knot. So you use get knot, the object, the indexed curve in the object, because there can be multiple curves in one object, will get it to you. Get knot, NURBS curve. No, this would be the NURBS curve inside of it. So I think you'd have to get the indexed curve, and then you'd have to get the index of the knot. Sorry, and then there's the set knot. Yeah, so sorry. You're probably going to have to use num knots, and there's probably like the get curve. Where was that again? MCC overlapping. Close, get knot, get CV. I'd have to dig through. It's been forever since I've used NURBS at all. There's got to be some way to do it. I'd have to dig through. Sorry, I can't give you a direct answer on that one right now. Let me go back up to those other questions. Yikes, where are all, how do, sorry Carlos, I can't give you a direct one on that. How to get the vertex position to use in create how do I get vertex position to use in create bone? Esteban, I don't know what you mean vertex position in create bone. There is no vertex position in the create bone. You're not setting vertices, you're setting objects. Or are you looking for all the vertex positions of the bone? Esteban? You need a vertex position to make a start and an end bone. Well, to get vertices, you need to use get vert. So you need to know what you're getting them from. So if an object is a poly object, you can use polyops get vert. If it's not, what you can do is you can capture basically, and you can make an instance of the object. And I just, off the top of my head, I just forgot. Oh shoot. The object dot mesh should get you the mesh. Oh man, why can't I remember this? Snapshot as mesh, I think you use. And you snapshot your object into memory, and then on that memory copy of your object, you can use the get vert, set vert values, and basically you can manipulate the vertices of that to be able to do what you need with. So if it's a bone or it's a sphere or whatever, those don't have a property to get at that value because they're not an editable vertex object. It's a parametric object. So what you need to do is make an in-memory copy of it with use snapshot as mesh and snapshot to a variable a copy of the mesh, and then through that you can go through with mesh ops or polyops, look those up in the help file, and you can get at the vertex data of that copy. Okay, so it's basically an exact copy of it. Does that help you, Esteban? Hang on, let me go back up here. Alexander, when something is not exposed in MaxScript recorder, how can I access the parameter, or some possibility to access it? Yes, look in the help file. I'd say about 95% of everything is not recorded. Do not use the recorder to find out how to do things, is what it boils down to. If I were you, I would use the help file to sort through and read and figure out how to do things. The recorder stinks in Max. Okay, it's not very good at all. And again, generally will even give you sloppy, bad code. You should be looking in the MaxScript help and determining how to get at it through really nice looking code and proper code that doesn't throw errors. That's the best way. Now again, with something like an object, you want to inspect it, you can use show or show properties, $, and there's all the properties of that object. If that's what you're looking for. You can use that on modifiers and on objects and whatnot. Does that help, Alexander? Kind of okay. Tom, back to your question previous. Yes, define common elements between set A and B. So basically, you loop through the scene and you're trying to compare two objects and find common elements. That isn't unordered, that has to be ordered, but it is how you go about doing those functions and how you write the search algorithms to do that. Now again, the world, you know, I mean, if you look at Google, they've been a master at writing search algorithms. So that is, you know, some of the things you need to look at. There is, there are search algorithms already available in MaxScript. Take a look at them, and functions in there. And you can utilize those for a starting point and start doing searches and whatnot, or write your own. But basically, it's not unordered. You still need to do it in some ordered fashion. And there are, again, multiple different ways of being able to do searches on things. If you wanted to find overlapping objects, well, I would suggest probably breaking it down into you know, a quadratic tree or whatever, a binary tree, and going from there. So where is it? How similar is Mel to MaxScript? They are not, Mark, at all. Yes, I know Mel. Totally different. Mel is the ugliest language I've ever seen. That's not knocking Maya. I think it's an excellent piece of software, but Mel itself is just horrible. It's funny because for years they'd tout how great Mel was. If you talk to any of the really good Maya TDs, they all use Pi now, and they try not to touch Mel because they've also figured out just how poor Mel is. The story went that Mel was actually developed by a summer intern at Alias when they were developing Maya, and she kind of did it as a side project, and they just kept it. But it is ugly and slow. I'd say it's probably half the speed of MaxScript when you start getting into the nitty gritty. However, what's nice about it and why everybody says it's great is Maya was designed to record everything it did quite well. So what I find is the amount of really bad written MailScripts out there is much higher than MaxScripts because you have to learn MaxScript to be able to write it. Whereas MailScripts, you get all these people that record everything they do and then they put it up as a useful script, and of course you click one button, it throws a pile of errors because there's just no error checking whatsoever. Down further, Python instead of Mail. Yes, Python's more closely related to MaxScript, really. Syntax is different again, but it's a much more robust language. Python's really nice and really easy to learn. I mean, I picked up Python in it seemed like minutes. I mean, I had to learn all the syntax unique things, but I took one look at it and it was like, oh, this is straightforward, and you just a matter of learning the syntax and the command lines. I'll go back to the IKFK switching your page is only IKFK blending, but I saw IKFK switch in Maya rigging tutorials. Okay, so the idea being is you want to be able to pop your IK to your FK and your FK to your IK is what I assume you're talking about, Alexander. And if that's the case, then it is about writing some tools to do it. I do it with the transform matrix again. You have to determine and store somewhere in the objects, and again, there's multiple ways of doing it, but let's say for the easiest way, let's talk about just sort of doing it name-based. If I needed to be able to snap this chain to this chain, what I could do is in my rig, I could store in the app data of this object the name of that object, and store the app data in the vice versa, store in the app data of this object the name, and vice versa, right? So they have knowledge of one another. I then write a function that basically says, let's align this to whatever it's supposed to align to, which is supposed to be this object here. And what it does is it reads into the app data, finds the name of it, uses a command called getNodeByName, and determines which node it needs to do. And then it finds the transform matrix data of this object and applies it to this one. So basically we can set up the snapping in that fashion. That's the way I go about doing it anyways. Sorry, Alexander, that answer? It'll probably be in one of my advanced master classes. Exporting to tutorials, .NET, writing, reading. This writes out basically all of the objects in your current scene in hierarchy, pumps out all the vertex data, smoothing group data, all kinds of stuff. I think, well, maybe it doesn't do that, the one that's in there. I think this is just an example. But it pumps out all kinds of information, and it uses recursive functions, and it goes through and pumps out all the objects or classes, and I think it even gets into pumping out more information like controller stacks and all kinds of stuff basically as it goes through. So right there, out as an XML, and then there's XML reading as well in here to be able to read in XML files. This is all done with .NET in MaxScript, yes. Okay, thanks. Tutorial will be cool. Do you know of any links regarding? Yes, I already read that one. Do you have a plan to set up an online school like Rigging Dojo? I have thought about it. Call it, this is the online school that we're doing right now. It's going to be current form until I can figure out how to keep pirates from stealing all the work. That's part of the issue right now. I'm not going to create another DVD ever again or downloadable data most likely because it'll be on YouTube in a week, and it's ridiculous. So unfortunately, I would suggest that the pirates out there think they're doing everybody a great service is actually probably hurting it, because the people who spend the time doing it, less and less want them to do it that are any good at it, because they're just not able to make money doing it. And hey, I do this because I make money. I like training and like teaching, but I got to make money at it, or else I can't feed my family. So I may as well keep the information myself and just do it for clients. Sometimes I find MaxScript evaluates from bottom to top. No, it doesn't. Such as callbacks. Is this true? No, it never evaluates from bottom to top, but it's a matter of scope. Print x equals 1. The print statement printed undefined because it came before the statement that actually created it. So, set the value on it. So there's no time that it ever evaluates backwards. It's about scope, and it's understanding how scope works and how the scope of things work. Callbacks have to be able to get scope to the things that they are calling back on and the code that they're calling on. So no, at no time does it ever go sort of bottom to top. It evaluates the code through the script from top to bottom, and you have to be able to keep track of that scope stuff. Any others? Had a little trouble connecting a parameter of one object to a floating rollout. It's like it's not the same. It has one attribute holder. Let's say. Had trouble connecting a parameter of one object to a floating rollout. Well, an attribute holder, attribute. I don't know what you're doing there, Carlos. I'd have to see the specific code. Were you parameter wiring? Were you instancing a controller? Were you setting up reactions? Were you, and how was the attribute holder written? Was it handwritten? Was it using the attribute editor? It's all one and the same, really. It's just MaxScript. So I'd have to see the specific code, Carlos. I really couldn't help you there on specific things. Say if I download a Max file with rollouts in the attribute holder without having the original MaxScript files, is there a way that the 3D MaxScript? Yes, you can actually get access to all of the custom attributes that have been written. They are actually MaxScript right in there. Look at custattributes.getDef, and you can pull any definition that's in a scene of a custom attribute out of it and get the full code with .source of the definition. And actually redefine that definition in the file without a problem. Will your .NET course address rigging tools? Not directly so much as, that's kind of what I do, so I can always talk about it, and I'll always be involved in things. For instance, when you're looking at my screen right now, the .NET tools here are all animation tools, basically. This one down here is actually a nonlinear animation tool set that controls mechanical devices, and it's all entirely .NET, MaxScript.NET. So this is completely customized UI for controlling animations. This one here is a facial UI tool set. Basically, I created joysticks for controlling facial controls and whatnot. That's incredibly involved, that one, but basically just that. These are, this is a control panel here that basically allows me to have custom control object shapes and save them out to XML files and read them back through a custom scripted plugin and display them that way. So, most of my stuff's all based around that. Thank you. Is Max better than Maya? I'm not even going to answer it. It's one of those things that, it's an infinite question, and there are better tools and there are better things that one's better at than the other. It's like any tool you go into. I can say, well, what's better, a screwdriver or a hammer? Or you could ask, here's a more specific one. A screwdriver or a hammer or a chisel, which is better? Well, the hammer's really good for hammering stuff in. Could you hammer stuff in with a chisel? Sure, you could bang it with the end of the handle, but quite frankly, the hammer's better. Could you cut notches out of a piece of wood with a hammer? Sure, use the end of it and hammer away at it. It's going to make a mess. The chisel would be better. What would be better is if you use the two tools together, and you'd probably get a better result. So the question is what tools are you talking about? What workflows? What are you working on? I think MaxScript is better than MelScript. Does that mean MelScript's no good? No, people have been using it in high-end productions for years now, and it's fantastic. So, it's not, it's neither here nor there. Do you have plans for a class on importing BVH on custom rigs? I hadn't thought about it, but that's an interesting one. I have actually written tools to do such. I actually don't do it from BVH, preferably. BVH is a pain format, but it's possible. I've written it to do it. I do it straight from TC T. I just forgot the name of it. Keep wanting to say TCP for tension continuity, but track row column, TRC data. And track row column is the actual markers themselves, not the rotations that have been derived from the markers, but the marker data themselves. I build my own transform matrix data from the marker data and apply it back to rigs. So that I have full control. So basically, I do all the mathematics that they're doing in software that does it. Have you tried any Python MaxScript hybrids? No. I started doing that, and I find the Python's great for the system stuff, and if I need to call MaxScript to it, but I haven't had to. I know a lot of people that do working in big production environments are doing that, but for my business, I tend not to work with clients on that level all the time. If they need that sort of thing, they tend to be hiring them directly in-house, and I've played around with it, but I've not had a big call for it, so I can't say I have. How do you deal with gimbal lock issues? Try to avoid them. So it's basically understanding how gimbal lock is caused and setting up parent objects and orientations and axis orders and whatnot. That sort of stuff's covered in my rigging classes and the direct rigging classes, Tong. So yeah, there's ways of dealing with it. You can't stop it. It's not possible to be stopped in any way, shape, or form. It will always be there. So I'll cover that stuff in rigging classes more. Well, yeah, you can do that, but then your animator doesn't have function curves. So they're not going to like you much. They're going to hate you because they can't deal with timing. So it's one of those things. There's a fight between mathematics and artists, essentially. And you need to find the smoothest passage from one to the other, basically. The best way I can describe it. One of those things. Programmers hate the artists, and the artists hate the programmers because there's a butting heads there somewhere where the two have to come together. TCB is quaternion rotation, tension continuity bias. One of the things they talked about when Character Studio 2 or 3 came out and then got added into Max is that it shows the function curves for TCB, and everyone we want function curves for quaternions because some other piece of software added them. Of course, they had no idea what it meant, and then they finally added them, and everybody went, "What in the world's this?" and had no understanding of what it is. And with quaternion rotation, there's actually 4 values, and they're all normalized vector values. So when you affect one, it changes all 3 of the others. Yeah, but how useful is it in Carlos and XSI to have a quaternion curve? Right. It's not. Have a look at it. Unless it's interpolating an Euler curve to display it. At that point, you're now running into gimbal lock. .NET's going to get more and more and more involved in Max and MaxScript as it goes. I believe they've stated that they're working on things like C# access and better access for Python and everything. So it's just going to get opened up more and more and more. Biped finally added the Euler curve, but it's still quats, right? No, there's an Euler controllers you can put on it, but it just never works right. Again, Biped is just, it's one of those frustrating tools that's locked out, and I tend to avoid if I can, but I mean, a lot of companies still use it. It's down and dirty, it's simple, it's fast and easy to use, but it is very limiting. Like trying to get MaxScript access to it, try and set the poses, your initial pose in Biped with MaxScript. Good luck. Simply not possible. Can't do it. It isn't that there isn't access there, it's grossly broken, and it always has been, and it'll just mess up. Every time you set the same value, it'll give you a different result in some cases. So it can get pretty ugly. All right, guys, we've gone over here a bit. I will call it at this point. I hope you guys enjoyed the class and got a lot out of it. If you did, please pass that on to everybody. I'm trying to get these classes rolling more and more and keep them full so that I can keep doing them and keep passing on information like this. The recording will probably take me about a week to get up and to pass on to you. I'll be sending you guys links to them. You'll have about a week to download once you've got it. I'm going to simply ask right now, please don't pass it around. Please don't pass it out and put it on YouTube. You know, I can do this because I can make a living doing it, and it can make me an income. If it doesn't make me an income, then I can't be here doing it. You know, I look forward to the further classes, like Esteban said there, the character skinning and other classes, and I hope to basically keep these things rolling and keep more and more interesting classes, and then start rolling back over the same ones again for new people again. Yeah, .NET class is going to be fun and interesting. In some ways, I'm still trying to figure out what the hell I'm going to teach in that one. I know what I kind of want to do, but I want to try and put it together in, again, some sort of cohesive direction. And so I'm sort of still struggling which the direction that's going to be. But I've got some ideas. So, are there any new rigging classes? Just what's on my site here. We've got current one, character skinning, which is all important because rigging is nothing until that point. Character rigging for blending, so I'm going to be doing facial rigging with blended morphs, sort of more and more beyond where we went with, if you've done my DVDs, then this will be recover some of that and then go further again. So and discuss new issues. And then, of course, the scripting one currently right now is the .NET in MaxScript, and we're going to get down into the how .NET works and how to call it and how to start utilizing it and adding it into your workflow. Maybe a class where we talk about your reg system. Well, that's totally proprietary, so we just did talk about it in some respects. Yeah, maybe further rigging classes will get into that deeply because that'll be more advanced stuff. So not necessarily specifically on my rig system, but I will be showing that sort of thing. Thanks, Paul. Looking for the face rig because the only face rigging tutorial I know. Okay, so great, guys. Thank you very much. I had fun too, and it's great doing these. I hope to see you guys at other ones. Again, pass around word that whether you like them or not. Okay, but certainly if you have issues or you have any feedback, email me directly. I'd love to hear it. Okay, whether it be good or bad, what you think worked, what didn't work. Whether you think you got your money's worth, okay? And I want to keep these things rolling as much as possible. Take care. I hope to see you guys some in the other classes, and have a good day or good evening, whatever it might be in your current location. Take care.